Assalamu alaikum warahmatullahi wabarakatuh. Welcome back to the Dynamic Engineer. Today's lecture is about the basic rules of lapping columns. There are some thumb rules, you can call it. These might not be the thumb rules, it might be the code rules, but you will have to keep it in your mind all the time so that you may face no problem during the construction process or during the design process. So today's topic is about the basic rules of lapping columns. What are the basic rules for design, for the lapping zone of column? This has been an important question for designers and for construction engineers. So today we'll be talking about that. Okay, so you can say these are 6 or 7 basic rules which you have to keep in your mind during the construction process or during the design process of designing up columns. Okay, so the first thing which has been discussed for years and still it is followed throughout the world, that what is the best place to lap a column. Okay, like if this is a column, let's suppose this is a slab, this is a column. Okay, so where shall we lap? And a column is coming from the bottom story. Okay, so where shall we lap the bars in these columns? Okay, this has been an important question. So the first thing, let's suppose divide this column into 3 sections. Okay, I'm dividing it into 3 sections. Okay, let's suppose this is the total length. This is the total length of the column L. So this section is L by 2. Sorry, not L by 2, it is L by 4. This section is L by 4 and this section is L by 2, which means if the column is of 4 meter, let's suppose it is L is equal to 4 meter, then this section is 4 by 4, which is equal to 1 meter. This section is L by 2, that is 4 by 2, which is equal to 2 meter, and this is again 1 meter. So we call it different zones of column, that is the zone A, zone B, and again zone A. So the best place to lap a column is the zone B. The first important thing, you will have to lap column in zone B. Specifically during high-rise building construction, you will have to keep this thing in your mind, that the lap of the column shall be in zone B. Okay, this is the rule number first that you have to keep in your mind for the for getting the best results out of any column design. Okay, this was the rule number first, the lapping zone. Okay, the rule number 2 for lapping of column is the length of this lap. Okay, so the length of lap. Now we all know the length of the lap shall be 50 D. Okay, but 50 D, what does that mean? Like let's suppose in a column we have 2 different type of bars. From this bottom story, number 8 bars, that is the 25 mm bars are coming from the bottom story, and here we will have to use number 6 bars. Okay, so 20 mm bars, I will call it 20 mm. This is number 8, this is number 6. Okay, so from the bottom story, number 8 bars are coming, and from the top story we will have to lap 20 mm bar, that is the number 6 bar. So there is a difference between these 2 diameters of bars. So what will be this 50D? Like you might get confused that this 50D means 50 multiplied by 25 mm or 50 multiplied by 20 mm. So you should have to keep this thing in your mind, that whenever you are lapping 2 different type of bars, the least diameter shall be taken for this formula, which means that we will have to consider 50 into 20 millimeters. This will be the lap length. Okay, lap length means this. Okay, so this length shall be 50 multiplied by the least, whichever is least. If this is number 6 and this is number 4, then you should have taken it is the number 4 diameter, and if it is 8 and 6, you'll have to take it as the diameter of number 6 bar. Okay, so this is the rule number 2, that length of the lap shall be taken as the 50 and to the least diameter between these two bars. Okay, so this was the rule number 2. The rule number 3 is the stirrup spacing. Stirrup spacing. Okay, now what will be the stirrup spacing? Okay, if you just imagine that a bar is coming from this side, this is a broken part of the column. You can say that this is a broken part of the column. So here we will be considering it as a weak point, and that is why the stirrup spacing near the lap will be less than the spacing at the extreme point. Like if this is a column, okay, this is the bottom slab and this is the top slab. Here, let me draw it on this screen. Here is the lap zone. Okay, then this part is going to be the weak point. Okay, and if it is a weak point, we will be needing extra shear reinforcement. We all know that stirrups are used for shear and also for buckling phenomena. We will be talking about it as somewhere else, that why stirrups are used, but here this is a weak point, and to strengthen this weak point we will have to use extra reinforcement here, and extra reinforcement in the form of stirrup spacing. Like here we will have to use more spacing, and in this zone the spacing of stirrups will be less than, you can say that in zone B, here I will explain it, in zone B the stirrup spacing will be less than at zone A, and the reason is very simple, that in zone B we will have to give the lap, and at that lapping point the stirrup spacing will be less than at the normal point. So this was about the stirrup spacing, that how much will be the spacing of the stirrups at a lapping zone. Now the fourth point is about the welding in columns. Welding in columns has been an you can say a destructive phenomena. Okay, this welding is a destructive phenomena, but that is not for all types of reinforcements. If you are using bars less than 32 millimeter, then welding is not allowed. Welding is not allowed. And if you are using bars more having diameter of equal or greater than 32, then welding is allowed. And there we have two different types of welding. Like the first one, and that is not normal welding. Okay, just keep this thing in mind, that this welding is not normal welding. We call it mechanical welding, and this is a specific type of welding which is used for this purpose. So the first thing is the mechanical welding, and the whenever you are lapping two different bars of diameter having diameter of equal or greater than 32 millimeter, then you cannot use simple lapping for this 32 millimeter. And the reason is because 32 millimeter and higher diameter bars are harder than this normal bar, so you cannot use simple lapping for this. You will have either to use the mechanical welding process or the coupler process. Let me show you the coupler picture, that what does coupler mean. Okay, so coupler is a type of anchorage between two bars. If you have seen this picture, here they have shown that a bar is coming from here, a coupler is used here, and another bar is going from here. So there is no lap in between these two, but the fact is this is working as a single reinforcement, and this is what we call the coupler. So either you will have to use the welding phenomena or the coupler phenomena whenever you are using bars of a diameter 32 are greater than 32. So this was about the building phenomena. Now let me clean the board, and three other rules which I'm going to explain it to you. Let me do it.